Hello, everyone. Welcome to our regular core protocol sync. We'll share exciting updates from the team from last week and plans for the immediate future. Shamil, as a tradition, you'll be the first.
Sure, I will share my screen. Can you see that? Oh, I think here it is.
It is loading. No, it's just logo for me. Okay, yeah, now it works.
Do it? Okay, then without. Okay, last week's I had improvements for DSM. I added a growing set of pieces providers for archival storage. This will strengthen our archival storage from the pieces side when we announce pieces from the partners. I also modified node pieces, adding an obsolescence for pieces from the node side. It will reduce in the future the cache size for the node. It will take it under control. Also, I fixed the last PR comments for the DSM metrics PR. I added a minor plot size check on the farmer side, and I started migrating our old code for block importing to the DSM v2 version. I encountered a strange issue when state root of the original block and imported block are different. It doesn't make sense for me yet, and I will continue working on this task. Probably I will ask Nazar to have a look on this. I also plan the next stage for the DSM. Oh, thank you, Nazar. It will be related to the object retrieval, and it heavily depends on the our research on the object mapping presence in the sectors in archival storage. So probably, Jeremiah, if you have time, please have a look on this issue. And that's it. I plan to finish
Can you guys hear Shamil?
Block this.
It's breaking up.
Yeah. Hey, Shamil, do you want to try switching to audio?
And
your stream is coming in pretty broken.
Okay. I repeat my last sentence then. Can you hear me now?
Yeah.
Okay. Let's continue to that issue later, probably at the last person of this talk. I will change the location.
Okay, thanks, Shamil.
Shamil, what was the issue you wanted me to look at?
I hope that you'll have time to look at object mappings in the sector.
Okay, is that like a Notion doc or a GitHub issue? Do you have a link to that?
Yes, I think I will send you a link to that.
Okay, appreciate it. Just for sanity check, make sure I understood you. So right now, with the changes that have been merged in, we can support sync of the plot for the farmer, correct?
Yes.
Okay, and what's the... Go ahead.
Yes, and since we don't need object mappings to import blocks, it is possible to import blocks with DSM, in theory at least. But to enable object reconstruction and object retrieval from the DSM, we need to introduce a concept of object mapping in the DSM v2.
Okay, so we can start building the node sync integration next.
Yes, I have already started.
Awesome.
I think the first version will be the version that we had kind of before, where you can start a special version of the node and it will try to sync from DSM, then you switch to the regular one. I think the full DSM sync will be the next step after that.
Okay.
This is
Awesome.
correct.
What's the estimated time for that first version right now?
Since it's already almost completed, because it's just a migration from the old version, it's basically I just finished coding and start debugging, and then I ran into this issue. So if we finalize this issue early, I hope that 1 or 2 days, and I will restore the old code.
Awesome. Yeah, that'll be great to test. Great work. Thanks.
Okay, thanks, Shamil. Continuing conversation about the core protocol side. Let me share my screen. Okay. Should be able to see it about now. From last week, just to focus on important parts, the first important part was this pull request about farmer components. Basically, before we had a farmer which had a lot of logic in it, including benchmarks, and those benchmarks were specifically done for auditing, proving, and for plotting, right? Like 3 big components. So what this pull request does, it basically takes those 3 components and corresponding benchmarks and just moves them into a separate crate. So on its own, this pull request doesn't do much. It's just like refactoring. But in the future, what we can do, we can allocate a piece of memory worth of 1 sector in memory, and we can just plot in there. So the plotter itself, as we had before, this is, let me see. Yeah, it should be this one. Plotting. Let me open the whole file. Yeah, plot sector, it basically takes the something you can write to for the sector and for the sector metadata. So basically, you can allocate 2 vectors. You can basically plot and farm in memory, which is very helpful for the execution testing, where we have node and farmer in memory producing blocks. And this is also helpful for the tests in the SP light client, where we also create blocks and we try to import them and verify headers and stuff like that. And we can actually use this for many different things. We had discussion with Ivan about this, where we can potentially use this in the SDK. However, this is a very low-level interface. We need a few more things on top of it. So for the time being, we will definitely use Farmer. And if you move some of those higher-level components into this crate, we'll basically move the whole Farmer effectively. So it doesn't really make a lot of sense. This is like low-level components such that we can just barely produce a block. We don't have object mappings, we don't have networking, we have nothing. We just have the core components necessary for the block production as such. So this is the first interesting pull request. I'll not go through the details. It's just like import changes. Any questions, comments about this so far? Awesome. Then as I was following changes from upstream from Substrate, I have noticed a few things that they've done recently, which made a lot of sense to me. We could just go through commits. So first of all, by default, when you are doing cargo build, it will try to update log file if it's out of date. So if you like change the minimum version and the version installed is older than that, it will bump it. However, it doesn't really do what we want to do in CI. In CI, we want to install things exactly from log file, and otherwise it should fail if it is happening. So all of the build stuff that we have in CI or for Docker files, we're basically extended with this logged flag for cargo that will ensure to follow log file all the time. Then in the CI pipelines, we had toolchain installation script, which is actually not really necessary. GitHub already comes with Rust pre-installed. Even if the version is not correct, we already have this toolchain file, which is called Rust toolchain toml, which defines the version we need and components we want to include. So this is basically a redundant step. As we are doing cargo test, it will actually pull the correct version if it's missing. So all of that is basically gone. It just simplifies pipelines a little bit, nothing major. And the stain is something I found in Substrate. They basically changed all of the like variable versions. Like this is version 2 point whatever, and it can be even malicious at some point. So what we've done instead, we've replaced all of the versions with exact commit hashes, which are supposedly not guessable. And there are some comments about what version that is exactly. And along the way, as you can see, I bumped a bunch of actions from like version 2, version 3, and stuff like that. It still works the same way as before, but it is like more secure considering that we are working with blockchain. So that's the primary motivation. It will be a little bit more awkward to upgrade, but we didn't upgrade it for over a year, so this should be sufficiently good for a while. So these are just minor improvements for CI, nothing major. Hope it makes sense. You can probably replicate some of this on the SDK and CLI side. Okay. Then, as I was working on the consensus implementation, there were some things I was preparing that I extracted into separate pull request and then rebased that one. In here, we had a challenge with the erasure coding. The reason for that was that we were taking a piece as a source. We were chunking it into 31 bytes because that's what we can fit in the field element. Then we were doing erasure coding and assuming that all of the 256-bit kind of outputs only have 31 byte of information in them. But since those are field elements, they can actually use up to 254 bits of information due to field element behavior. And when we were truncating it to 31 bytes, we were basically throwing away information. That's why it wasn't the same as when we are trying to decode it again. So that was the test for that case. And then I moved the farmer protocol info into the components because that's something required for farmer to work. It was awkward to depend on RPC crate. And then there were some changes necessary for benchmarking to run. I didn't run it successfully, as I mentioned on the DevSync. We had upstream issue in Substrate that was fixed, and I have merged it back into our fork. But for the time being, it at least compiles. Before, there was a comment on the forum that when you enable benchmarking feature, it actually doesn't compile at all, like it fails to compile. So at least it compiles with this pull request. And on top of that, we have the consensus itself. This is basically version 2.2 consensus. So the notion of sectors is still present. It's just what sectors contain is slightly different. So in our case, sectors contain columns. Each of the column is a piece. And then we have as many of those columns as we have basically filled elements in every piece. And then we are doing erasure coding like in the opposite direction. So we take the first chunk, which is 31 byte from every piece. We do erasure coding, then second, then third, and with like row by row, we are going through them. And then we are creating commitments over encoded pieces vertically. So you can just think about it as a square of field elements. There are some benchmarking. The benchmark performance actually went down, but I think we can tweak a little bit about that. And these are slightly outdated. This is not the final implementation that I've done here. And you can go to the Notion page to see what version of that we are actually implementing. What else to say about this? Yeah, there is a trick in the implementation due to that truncation of the field elements I mentioned. So basically what we are doing, we are treating piece, like the source piece after the archiving in the blockchain, as a series of field elements which are 31 byte each. However, we are treating a sector as a grid of 32 byte elements. So before we are actually constructing a sector, we are adding one empty byte to every single chunk in the piece. Then we are doing encoding. And then after decoding, we are removing that 0 byte in the end before we reconstruct the original piece. It just makes sure that during encoding, decoding steps, we always have the same size. So the sector size is not multiple of the pieces anymore. It's like multiple of pieces plus those extra empty bytes that we need for this thing to work. It doesn't mean that for every 31 byte, we waste one more byte when we are writing plot. We might actually do something in the future where we are trying to chunk a piece into 256 bits of information, but it's really awkward to deal with. That's why we are doing bytes for now. If this is the final version, we can go into like more advanced implementation and optimize it. So we are only wasting 2 bits instead of the whole byte. Otherwise, you can read details here. You can follow the link into the Notion. Yeah. Any questions or concerns about this?
I would just second that we shouldn't worry about that 1 byte overhead at all right now until we finalize the scheme.
Yeah.
And if we have to hack it, no big deal. So I think you're on the right track.
Awesome.
Yes, I also have a question about that. Some intermediate version had some issues and produced 100 votes during the work. We were able to fix that issue. Is it correct? Because my last test didn't show that.
Yeah, the very first version suffered from that problem where encoding didn't match decoding, as you remember, and that was caused by truncation. So what initial implementation did, it had the performance characteristics of the final version, but it was actually throwing away the results of encoding, and it was actually not decoding anything. So that's why input and output were always the same. And especially as you are plotting the very first block, which is just all zeros, you have many chunks in the piece which are actually the same. So when you do hit the solution, you actually had like hundreds of them or thousands of them. And that was the source of that like flood of solutions that you had. In this final version that we merged, we do have encoding and decoding, so they are unique. And because the performance is not great and it doesn't really make sense, I have actually placed a limit on how many solutions farmer will try to return, and it will just stop at the point where it hits that count. I can try to find it quickly. Or was it here? I don't remember. Let me see. Yeah, solutions limit. Basically, we'll try to produce at most 10 solutions. Otherwise, it will always run out of time. It will not be able to produce a block at all. So this is a small workaround, but realistically, if you have any kind of real world network, it's unlikely that you will produce even 10 solutions for the same time slot. So that's not a big problem.
Okay, thank you.
Okay, let's move on then. I can probably go into the Substrate upgrade a little bit. The basic challenge was that everything worked except in CI. And in CI, we were running out of space on Windows platform specifically. And in order to fix that, I have noticed that in the latest version, they're using WASM opt crate for the optimizations of the runtimes in some places. And that was compiling for a long time. That's why CI got slower. And it also actually takes a lot of space once it's done. And the reason for that is that the way Substrate tooling is designed, it will compile every runtime WASM in like a separate subdirectory, isolated from the rest of the project. So it doesn't unify features, and it can target WASM instead of targeting x86 or ARM, whatever platform you're on. And it actually leaves that folder in there. Like it produces WASM file, and then it leaves all of those intermediate build artifacts. And you have basically multiple of those target directories instead of just one. And they don't share any dependencies between them. And they turned out occupy a lot of space. So what I did, I have submitted upstream suggestion to have this new environment variable, WASM build clean target, which if you specify, it will build WASM and then delete the target directory completely because you don't need it anymore. That's especially helpful in CI where you just compile it once and then you move on. You never recompile, so there is no benefit of keeping the directory. And then I hit another problem on Windows. Turns out you cannot actually run as something as simple as cargo clean. It just fails to delete one of the directories, which on Linux is a symbolic link. I don't know what it is on Windows, but the root problem still persists, and it just doesn't work. So I have submitted that upstream to the crate that was problematic. I don't know if there is a link somewhere here. Yeah, if you follow this one, and then you will find it. Yeah, here. Basically, it's not. Yeah, there is another one. If you follow the links, you can find it. Basically, I was fighting, trying to make it work, like attempts, retries, timeouts. What I ended up doing is I just, for Windows, decided to delete a few very specific directories that have a lot of space, and that was just sufficient for us to move forward. Hopefully, they'll fix it in that crate. There are some very smart people maintaining that crate, so hopefully they'll figure it out. So in Windows, we have just 2 locations we delete. On other platforms, we delete everything as we should. So that was the last missing part that allowed us to upgrade Substrate. As a reminder, there were many things that have changed here. It's quite big. There is a small digest here, and there are some discussions. Hopefully that makes sense. And yeah, we've updated Rust once again after that to fix documentation. Yeah, I think that's it on my side, unless you have any questions.
I remember when I was learning how to code, the first engineer I worked with, he was also Ukrainian, and he was explaining to me about the difference between Windows Server and Ubuntu, Linux. And he said, if you're ever working with someone and they want to use Windows Server, you should run the other direction as fast as possible.
I feel them. It's always either Windows or something obscure related to ARM versus x86 on macOS. Like those are 2 sources of challenges with compilation recently. Okay, so that's on my side. And on Shamil, Ivan, do you have anything to share this time?
No, just following the updates from monorepo.
Okay. There was one thing that was discovered. Basically, if you specify something like 10 megabyte for the plot space, it will hit a strange error in FS2 crate, which is apparently platform specific. But the reason for that is that you are trying to allocate 0 bytes. And our library should not even allow you to plot 0 sectors. It doesn't make any sense. So that's something that Ozgun will submit a pull request tomorrow, he said. We were checking it before in one way, but that was like very small, like 1 megabyte, I believe. Ivan put a limit. Doesn't make sense to go below that, but now we have even bigger minimum requirements. So that's something Shamil changed in the CLI, but on library level, it was still possible to plot 1 sector, at least to try, and it will panic. So that's something we'll fix. Okay, Lu Cheng, do you have anything you want to share today?
Actually, nothing to share on the code protocol side, but like we have coming changes like on the code protocol, not on the primary chain nodes, which are required for the execution layer, and that like already has a behavior for that, which is like basically to add some modifications to the current existing like transaction pool wrapper on the primary chain, which is to like to make use current primary chain network as a global executor network to like transport the messages between executors. Okay, not exactly between the domains. So since those messages are basically wrapped in unsigned extrinsic, so specifically they are to transport the unsigned extrinsics. So here is the background. Okay. Currently, all the domain nodes like are kind of a sidecar to the primary chain node. They all run like in isolation without connecting to each other. I'm not sure if recall that we disabled the traditional like syncing between the domain nodes. So that means we have no network for the executors. They cannot connect to each other. That means
I mean, we don't, but we could.
Yeah, but it had some issues, and so we decided now it's like it doesn't worth to spare more time to investigating. So we simply disabled that syncing, right?
Yeah, the syncing part, yes, but for other messages like syncing transact or like sharing transactions, gossiping transactions, it might still make sense to have network in there.
Yes. So that's why we would like to make use of the primary chain network as the global network. So we're not to fix the network issue between the domain names. We would like to make use of the primary chain network as this global executive network to transport those messages for the domains. So that is all these messages for the domains will be wrapped in an extrinsic of a primary chain unsigned extrinsic, and that will be shared between all the primary nodes, and all the executors can access. They have a primary node. So whenever there's a transaction received from the network, this a transaction pool will try to intercept and to dispatch those if this unsigned extrinsic is specifically from the for the domains, they will dispatch those messages to the right destination, which is the related domain transaction pool. So that's
Okay, is this a temporary solution? Because we wanted farmers not to care about all of those bundles that executors have to share. And in this way, we are basically forcing them to re-gossip everything.
Not exactly. They still have to care about bundles. They just don't care about the content of the bundles. So they're just checking the bundle header. That is part of the long-term design.
Well, checking, yes, but they still have to have bandwidth for all of the bundles, and that is scalability challenge, right? We want to keep
Absolutely,
just headers.
right. Everything right now, well, yeah, but that's not going to be until post mainnet beta that we do anything to decouple the scalability side. Right now, it's just going to be standard farmer full node bandwidth.
Okay.
For this step, at least.
And I even imagine if we can have our own networking layer, which we can be free from the current substrate networking layer, coupled all the thinkings transactions, blocks. If we can just don't have this limit, they maybe simply disable this block thinking and still have the other thinkings. I mean
Hopefully,
transactions.
that's the plan.
Yeah.
I think after we have blocking port from DSN, that's something we'll be looking into more closely.
Yeah. And at that point, we can have nicer solution, I believe.
Okay, makes sense. All right, Ning, do you have anything you want to share?
Oh, not really. Just following the update.
Okay, sorry, I lost internet for a little bit. Daria, what about research on your side?
Well, apart than the bug that you mentioned that we have fixed Hooray, that took a while and became an obvious solution that we were just truncating some bits, but I'm glad we found it. Then after a part of that, I was working mostly on studying how we could commit to commitments to have like before we had for archival sectors and plots, we had like a Merkle root that was committing to all the piece hashes. We'd like to have something similar for the KZG commitments to pieces. And so I'm studying how that is done. And there is a paper called inner product pairings proofs. And I was looking at their code. However, the issue with their code is that to be able to produce any proof to like a chunk, they need to read the whole sector, which, well, if we want to have them bigger, is not really doable. So I ran the test based on the like the implementation that they had in ArcWorks, and the test for 128 1 megabyte pieces was running for 2 minutes just to commit and compute one proof. So that's like absolutely not acceptable. And so I was trying to decouple that to see whether by adding some cost of pre-computation of proofs, I could avoid the time and I could decouple to avoid reading the whole sector. So I'm playing with that mostly these days.
Actually, the version 2.2 implementation we have right now, it does read the whole sector when it produces a solution because it needs to decode it. It's just the pieces are 32 kilobytes, and we have like 1056 or something of them. So it is much smaller scale, and maybe it will be okay in that case.
Yeah, but I'm not sure what's. I already don't remember what was our long-term plan if we have already settled on the sizes of the sinks, and so I would like to avoid that because, for instance, if you use something like a vertical tree, it's much faster. You don't have to read the whole sector. You just have to, you commit to a column, and then you have the column commitments, and then you commit to like hashes of those or something like that, which is not ideal, but it's super fast. This does it commits like directly to KZG commitments without reducing them to like a hash or a scalar. But though the base test took me 2 minutes just to produce like one proof, to commit to everything and produce one proof, which is a lot for 128 megabytes. So yeah, I'm looking at whether I could do some pre-computations to avoid that, whether we are going to ever use it. But yeah, that's where I'm at now.
Okay. Jeremy or Jeremiah, do you have anything you'd like to add?
Not from my side.
Me either.
Okay. Thanks, everyone. I think that's all we have to share for today. But don't worry, come next week and we'll have more updates. All right. See you. Bye.